If a skateboarder glides onto the bottom of a ramp of angle 5 degrees with a speed of 4.0 meters per second, what maximum height on the ramp will they reach, assuming that non-conservative forces act directly opposite to their motion with a magnitude equal to 1/5 their weight? So this is one of the more difficult problems for this unit. Not only do you need to apply the new concepts of mechanical energy and non-conservative forces, you also have to apply some math skills, like trigonometry skills, as well as try to figure out what some of this wording means. Like the last part says magnitude equal to 1/5 their weight. You probably have not heard that kind of language used before. So I want to try to break all that down for you, and then you can practice some problems on your own. Okay, so we have a skateboarder who's going to glide onto the ramp at the bottom here. So this will be point 1. So at point 1, it says the speed of the skateboarder is 4 meters per second. And I am also going to say that the height here is 0 meters. So I'm basically saying that this is going to be where my reference height is. Then the skateboarder is going to glide up the ramp until they reach some kind of a maximum point. Okay, and we're asked to find out what this maximum point is. Okay, so we're just assuming the skateboarder is not going to pump his leg against the ground anymore. He's just going to glide until they gradually come to a stop. So this height which I'll call h2, is what we are asked to find out. So that's question mark. As well, at this point, this maximum point, I can also label v2, the speed here, is 0 meters per second. Okay, the skateboarder has run out of momentum to reach the maximum point, so they come to a stop there. Maybe they'll roll back down the ramp. If they don't do anything, gravity will pull them back down. But we just care about that exact moment where he reaches his maximum spot. Okay, so what about in between? So this is a 5-degree ramp, and it says that there's non-conservative forces opposite in direction, and in magnitude it's equal to 1/5 of their weight. So in terms of the work done by non-conservative forces, which I'll label W and C, I'm going to kind of explain that. I'm going to explain that with a heading here. Use more space. Okay, so the non-conservative forces, the magnitude of it is 1/5 the weight. So that means 1/5 of mg. So you have to go back a few weeks to the word weight. Weight is the force of gravity, which is m times g. So that's what magnitude of 1/5 the weight means. In terms of direction, it says that it's directly opposite. Directly opposite. So that means that the theta used in the work formula is going to be 180 degrees. Now what about the displacement? Okay, what's the displacement there? So that's a bit tricky. It's the hypotenuse of that triangle, the 5-degree triangle. So I'm actually going to apply the sine ratio. So sine of 5 degrees, just looking at that triangle there, is opposite over adjacent, opposite over hypotenuse. Now the opposite side to the 5 degrees is our height, h2. And the hypotenuse is the displacement. So when I rearrange this, my displacement becomes, it'll become h2 over sine 5 degrees. So that's an expression for displacement. So in terms of the work done by non-conservative forces, W and C is going to be force times displacement times cosine of theta, or cosine of 180 degrees. So that's going to be 1/5 mg. That's the force we got. Times h2 over sine of 5 degrees times cosine of 180 degrees. And when I simplify all of that, so cosine of 180 degrees is -1. I'll just combine the denominators together and the numerators together. So this is going to end up being negative mg h2 over 5 sine 5 degrees. So that's my expression for the work done by non-conservative forces. And that's why this question is so complicated. So now, going back to the problem, I need to apply the conservation of energy. So starting kinetic plus starting potential plus the work done by non-conservative forces equals the ending kinetic plus potential. You can cross off things that are 0. So my starting height was 0. That means my starting u value is 0. And my final speed is 0. So that means the final k is 0. So to cross those out. Okay, now I will change my k into the formula for kinetic energy, which is half mv squared. I will change the w and c to what I spent all that work doing, what I have in that box there, which is negative mg h2 over 5 sine 5 degrees. And I will change U2 to the formula for gravitational potential energy, just mg h2. All right. Now, with this, I need to eventually solve for h2. I need to eventually solve for h2. That's the question. And I'll plug in the numbers to everything else. I know the value of g is 9.8. I know my starting speed is 4 meters per second. But what about the mass? We are not told the mass of the skateboarder. But we don't need it, because if you look at the equation I'm at now, there's 3 big terms in it, but all 3 of them have mass in it, or in its numerator. So if I divide both sides by mass, it actually just cancels out. So you don't need the mass of the skateboarder in this question. Okay, I'm going to keep going. So, yeah, I'll fill in some numbers here. That'll be the simplest way. So half V1 is 4 squared. Then minus, I'll do 9.8 for the G value. Equals 9.8 H2. Okay. I'll simplify some of these numbers. So the first term, half times 4 squared, that's half of 16, that's 8. So 8 joules there. Second term, get my calculator out. 9.8 divided by 5 sine 5. You have to do that kind of carefully in the calculator. I'm getting 22.49. I'll keep an extra couple of digits here just because to be more accurate. I'll underline the 2 sig figs that it's supposed to be though. Equals 9.8 H2. Okay, what I'll do from here is I'll try to collect like terms. So I will add 22.49 H2 to both sides so I can combine those H2 terms together. So kind of bring that over there. So 22.49 plus 9.8 gives me 32.29 H2. And now I can divide both sides by 32. Giving me 0.25 meters. So the maximum height reached by the skateboarder is just 1/4 of a meter, basically. That doesn't seem very high, but remember this ramp is only 5 degrees. So I can actually figure out how much that is in terms of displacement. Going back to my formula that I have there, d equals h over sine of 5. Okay, so it's actually 2.8 meters in terms of the displacement along the ramp. That still doesn't seem like very far, but that's what the math says, so that's what we'll go with. All right, so you can try some practice questions. They're not going to be as involved as this one was. I just kind of wanted to show you kind of like almost a maximum level of complexity so that you'd have the tools to hopefully do the practice questions.